Hello, good evening everyone. Am I audible? Can please someone confirm if I'm audible?
Yes, sir.
Okay, so we shall wait for maybe 2-3 more minutes and then we'll start the session. Okay, so good evening everyone. I hope I'm audible. Please confirm again so that we can start. Am I audible to everyone?
Yes, sir.
Okay, so let's start this course, which is Introduction to Semiconductor Devices, which is taught by Professor Naresh Kumar Irmani from IIT Hyderabad. And I'll be assisting you in solving some of the similar assignment problems. And I'm Anant Singhal, a PhD student from IIT Jodhpur. So we'll be going week by week. We have a course outline in which we have classified certain topics for each of the week, and we'll be solving or try to solve very similar problems which are given to you in the assignments. And we'll even try to solve some of the assignment problems if the deadline is there. Uh, so yeah, so this is the course outline that we will be covering in the coming 12 to 13 weeks. Uh, So we'll start with the first week with a very basic topic such as semiconductor in daily life. Then we have semiconductor material properties. Then we will see some of the energy. Give me a moment. Yeah. So we'll be starting with a very basic topic from week one, which is some of the energy level topics such as photoelectric effect, such as de Broglie wavelength, such as uncertainty principle, which is taught to you in the initial classes, and which basically lay the basic of this particular course. And I'm telling you, this is a very good course for those who are interested in the job or even in the research for the semiconductor electronics. If you know about this course, like if you know this whole content of this course, you will be able to be placed in any of the semiconductor company. I can make sure of that if you are aware of all these concepts. So this is a very good course. It's good that you all have registered from the same, and I'll hope for a very good participation from the students in the upcoming weeks. So let's start with the week one course outline, which is some of the very basic questions. So I'll directly go towards the question. So initially, if you have any question, you can ask right now, and otherwise I'll start. So you can maybe you can type, or you can say if we can start the course directly, or if you have any query right now, you can ask straight away. Okay, so shall we start? Yeah, someone has raised. Is there any query? Okay, fine. So I guess we can start with the very basic. So I guess in the initial topics of the chapter, what we have understood or what we have learned basically is some of the very basic topics, such as photoelectric effect was the first topic that is covered in the course. Then you might have read about the wave duality uh, principle, that is, a electron can act both as a wave as well as a particle. And then there is uncertainty principle that you must have read in the course, that is basically given by Heisenberg, in which you must have read that the position and momentum cannot be simultaneously measured. So these are the very basic, or the this all will lay the basis of this particular course, and will be going one by one towards these topics only for the first week. So uh, first of all, what is photoelectric effect? We all know that. So I'll like very briefly cover the contents of the course in the initial part of the lecture, and then we'll solve the assignment problems, which are similar to the assignment problems that are given to you in this year. So we all know that this photoelectric effect, in short, if I can say, this is given by Max Planck, and it says that if we have any incident light, then the energy of that particular light is quantized in the form of energy quantas, which are also known as photons. And this energy, quantized energy, is nothing but energy of a photon is given by equals to h nu, where we have this nu as hc by lambda. Like this is a very basic formula that we all know even from 10th standard or so. So this is a very basic of photoelectric effect, and what it states, it's, let's say if we have a metal and we have some incident light on it with the energy of h nu, so what happens is there can be some absorption of the light and there can be some reflectance of the light. So this reflected particle is known as, also known as photoelectron, and this phenomena is known as basically photoelectric effect. And the second part that is covered is a de Broglie principle. So what de Broglie principle states is, can anyone tell what is de Broglie principle? Okay, okay. So sure. I'll lower down the pace. So basically, what I was trying to do, I was trying to quickly cover the contents of the course, because most of the time what we want to spend is on the assignment problem. So the problems that I'll be solving will be very slower as compared to the theoretical part. So that is why I was covering it fastly. But yeah, I can go slow for the theory also. So yeah, so can anyone tell what is de Broglie principle?
Sir, the de Broglie principle says that matter can exhibit dual properties, that is, wave property as well as particle property simultaneously.
Yeah, so that is correct. So let's say if I consider a electron, so what de Broglie principle states that electron can also act like a wave. Okay. By wave, what we can say is it can exhibit some of the wavelength, it can exhibit some of the frequency, etc. And it can, and it also exhibits properties of particles. By particles, we can say that it exhibits momentum or energy, you can say kinetic energy, etc. So this is a very basic of de Broglie principle, and this basically this duality is the fundamental to these quantum processes. And yeah, so what de Broglie proposes, as I said, that electron possesses both the properties of wave as well as particle. So he proposed a wavelength formula which is nothing but h by mv. So this lambda is covering the wave property of the electron, and this velocity is covering, sorry, the particle property of the electron. So this is what de Broglie proposed. So what we have like in the assignment problem, so I'll be trying to solve all the problems, but yeah, since you have a deadline, so I cannot share the answers for the given assignments. So you should for each of the question you should tell me if the assignment problem is the same, so that I can maybe make some changes in the question and solve the same. Okay, someone is sharing a screen. Saranya, please stop sharing a screen. Okay, yeah, so let me share it again because this was some glitch. Okay, yeah, is my screen visible to everyone? Uh,
Yes, sir.
okay, fine.
Yes, sir.
Sure, sure. So as I was telling that some of the problems can be very similar to the assignment problems that is given to you. So I cannot be biased and give you the answers directly. So kindly let me know if the problems are exactly same so that I can change the problem at that moment. So we'll be like covering very few very basic problems. First of all, on the basis of the de Broglie principle and the photoelectric effect. So is there any doubt till now, or we shall go to the problem?
No, sir, you can proceed for the
Sure.
problem.
Okay. So this is the first problem. I guess this is given in this year assignment only. That according to this de Broglie hypothesis, all matter exhibits wave-like behavior as well as the particle behavior. We already have read these things. So among the following particles, which one has the smallest wavelength? So there are some different options that are given. So first is the electron, second is a, I guess, proton, and then we have maybe a cricket ball or something like that. So I guess this is a very easy question. So you can give it a go. Maybe you can take 2-3 minutes and you can try it out. These three are the options that we have, and you can type your answers in the chat box, and then we'll solve the problem. Like I'll solve the problem after 2-3 minutes. So you can try it for 2-3 minutes. Okay, so I've already got some of the answers, which is ball that or most of the people are assuming. Okay, so let me solve it simultaneously then if you already know. So this is a very basic problem. So we have already read that the de Broglie principle states that we have a lambda which is nothing but h by mv. So it is given in the question that all the particles are having a similar velocity. So this particular v in this question is constant for each of the particle. So even if I try to solve for an electron, let's say, so we know that the what we know is we know the charge of the electron. It is nothing but 1.6 10 to the minus 19 coulomb. Then what we know is we know the mass of the electron, just 9.1 times 10 raised to the minus 31, and this is in kg. Then let's say we are considering the velocity of electron as 10 raised to the 5, which is the limit of the thermal velocity, meter per second, let's say. So we'll now calculate the wavelength. So wavelength is nothing but lambda h by mv, and we already know the value of Planck's constant. This is nothing but 6.626 times minus 34. then we have a certain mass, and then we have a certain velocity which I have taken as 10 raised to power 5. So can someone quickly tell what is this number coming out? So yeah, you should keep your copy and calculator with you all the time when we are solving the problem. So this will come around 7 point something. Uh, yeah, so this will come around 7 point something into 10 raised to power 9 meter. So that will be around 7 point some nanometers. So we can see that we have a, let's say we are getting maybe 5 or something like that. So we can see we have a significant wavelength in this particular question, which is for this particular case for the electron, which is coming out to be in few nanometers. But if we go towards let's say a proton, which is the second case, so we will have the same things. What we will, or we can go directly to a ball, because that is what we are going towards. So if I even assume a tennis ball to have, let's say, some half a kg or even 50 milligrams of weight, you can say it's 0.05 kg. So if, let's say, if I keep this weight and again the velocity is same, so if you will be calculating the particular part, so what we have done is we have reduced the mass from 10 raised to power 31 to, let's say, 10 raised to power minus 2 kg. So we clearly see a um, decrease in the wavelength. How? By a order of, let's say, 10 raised to power 29. So this will be coming like greater than let's say 10 raised to power minus 30 or something like that meter. So we can see that we don't have any significant wavelength here. Do you understand what I'm trying to say? So for a, sorry, no, the electron and proton will not have the same wavelength. So the effective mass of the proton will be higher. So for a electron we have 10 raised to power minus 31. Then for a proton it will be a bit higher. It will be in the order of 10 raised to power minus 27 kg. So we will have a smaller wavelength for proton, but even smaller wavelength for a tennis ball, because we have a very high mass as compared to atomic particles such as electron and proton. So for a tennis ball, we are getting, or for an electron, what we are getting the wavelength in the range of nanometer. But for a ball or any case, we are getting it in the range of 10 raised to power minus 30 meters, which is very less as compared to if we see in terms for electron and proton. So higher the mass of the body, we will have a smaller wavelength. So this is what the question has asked. So a higher mass will give you, for us equal velocity, a higher mass thing will give you a higher uh, or a smaller wavelength, not a higher wavelength. So what we can conclude from this question is, we can say what mass can do with the wavelength. Or we can say that the larger particles cannot be treated like a wave. I hope it is clear. This is a very basic concept from the de Broglie hypothesis. So if you have any doubt in this particular question, you can ask. Okay, so now the pace is fine. Whosoever was saying that the pace was a bit faster, is it fine now?
Yes, sir, it is fine.
Okay. Okay, so after this, what we have in terms of basic is the theoretical part is a Heisenberg uncertainty principle. Can anyone tell what is Heisenberg uncertainty principle? Which have the smallest wavelength. So I've got a doubt that which have the smallest smallest wavelength in electron. Okay, so from electron and proton, electron will have a higher wavelength because it has a lower effective mass. A proton has a higher effective mass, so it will be since it has a higher effective mass, so it will give you a higher wavelength, right? As I said that higher the mass, we are getting a smaller wavelength. This is very basic because the wavelength is so low that we cannot treat even the large particles as a wave. They are only the particles. So duality exists only for atomic particles. Does it make sense? Higher mass will give you a lower wavelength. The the expression is quite evident. I mean, if I can write lambda is h by mv. So higher this mass will be, lower will be the wavelength. If we increase the denominator of this particular term, we will get a lower wavelength, right? Yeah. So yeah, we can go forward, I guess. So can anyone tell what is this Heisenberg uncertainty principle?
Sir, it states that the position and momentum of an electron cannot be determined simultaneously.
Yeah, exactly. So as he said, position and momentum. So these are the two things for any electron. They cannot be determined simultaneously. And what we have got the relation as the change in position and the change in momentum is always greater than equals to dot square. I hope you already covered all of these things in the theoretical classes. So that is why for the theory, I'm not going into so much deep. So what it is saying that the uncertainty in position and in momentum cannot be measured simultaneously. And this is why even for the further course that you might have read for the Fermi levels and all, so that is why we cannot tell the position of the electron. But what we try is to find the probability of the electron in any conduction on the valence band. So this is the basis of that particular thing, that in Fermi level we are calculating the distribution function, which is giving out the probability of the electron rather than giving out the final position of the electron. We are more interested in giving out the probability. Why? Because we cannot measure the position and momentum simultaneously for any of this device. So does it make sense? I guess I don't need to go deep into this. This is very evident and very basic. So maybe what you can do is you can try out this question. You can take maybe 2-3 minutes. This is a very simple question which is based upon this Heisenberg uncertainty principle. So what is the question suggests is we have uncertainty in position given to a certain value. We have a finite momentum that is given, and what we need to find out is the uncertainty in the kinetic energy, and that too in electron volts. So you can give it a try and maybe type your answers in the chat box. I'll give you 2-3 minutes and then I'll start solving it. And please simultaneously you can tell me like about yourself, a very basic introduction, like what you are pursuing, which year you are in, and from which college or from where do you belong. Uh, if you are hesitant to tell it over by opening your mic, you can even type in the chat box. That is fine by me, but it would be better if you can one by one open your mic and let me know. Yeah, sure. Whosoever has raised hand, you can tell. Maybe Swathe SPC first. Am I audible, Swati? Hello. Can someone confirm if I'm audible?
Yes, sir, you're audible.
Okay, so I guess he's having some trouble with the mic. So maybe Sangavi, you can introduce yourself.
I am Sangavi from Shakti Polytechnic College, Erode. I am studying Triple E second year.
Okay, so you are a second year student. Yeah, that's fine.
Yes, sir.
Uh, yeah, anyone can go next. Yeah, sure. Saloni. Um, you are not audible, Saloni, if you are trying to say something. Anyone else can you?
Good evening, sir.
Yeah, yeah, Swati, I can hear you.
I'm Swati from Shakti Polytechnic College, Erode, second year student, Triple E.
Okay, so the same college from where Sangavi is, right?
Yes, sir.
Okay, okay. Uh, okay, so I'm getting some of the chat box. So you are studying from Andhra Pradesh. Okay. Fine, yeah. Anyone can go next. Like whosoever feel like talking, they can. Otherwise, they can type in the chat box. Everything is fine by me.
Sir, I'm Sushovan Maiti from West Bengal. I am a second year undergraduate student of Electrical Engineering branch, and I'm currently pursuing this degree from Jalpaiguri Government Engineering College.
Okay, yeah, great.
Sir, I am
Hello, sir.
Sanjay.
Yeah,
Okay.
Sanjay, you can go first.
Hello, sir. I am Sanjay from Chennai. I am studying second year Ishwari Engineering College in Ramapuram.
Sorry, in what?
Ramapuram.
Which
Place, sir.
branch? Which branch did you say?
Chennai, sir. Chennai
Uh,
Ishwari Engineering College. SRM Ishwari Engineering
no, I'm
College.
asking your branch, like electrical, electronics, what it is.
Electrical second year Electricals and Electronics
Okay,
Engineering, sir.
okay, yeah,
Okay, sir.
nice. Yeah, yeah. Om, you can go now.
Hello, sir. I am Om Gaike. I am pursuing electrical and computer engineering from JNEC MGM College, Chhatrapati Sambhajinagar, Maharashtra.
Okay, yeah, that's great. So I'm getting some of the queries. Yeah, so whosoever is interested in VLSI, so this is the very core course that you should all know. Like in the further part of this course, we'll be going towards MOSFETs, MOSFET, BJT, and junctions, etc. So you should be knowing all about the basics of the devices to go into VLSI. So since we all know that there is a huge scope in VLSI right now in the industries, uh, I guess some of you are second year students, so after 2 years there will be more opportunities after the setup of Micron in Assam and Gujarat. So you should be studying this course. Like, you have already made a good choice by taking this course, so you should be attentive in all the classes given by Professor Imani. Then you can come regularly to this live sessions that will help a lot in solving the problems that you have. So if you have got a good assignment and exam for this course, you will be having a certification, so that will help you a lot in getting the jobs. And for the YouTube channel or playlist, like there are various playlists, so maybe I'll share it in the next class for the particular links that you can follow for the VLSI. But VLSI is a secondary part, so first you need to cover the basics, that is the device part, and then you can go toward the circuits and VLSI. So I guess for this particular year, if you are in the second year, you should like deep dive into this particular course only, and after that you can start studying for the VLSI aspect. So there are even NPTEL courses given by different professors for VLSI also. So you can also enroll in them, enroll in those particular courses. That will help you a lot. And for this particular course, so these all videos will be uploaded on my YouTube channel. So like these particular session only, like we are going towards solving the assignment problem, so I'll be uploading this in my YouTube channel. So maybe I can type it out, you can search it. There will be a YouTube channel if you search my name by writing NPTEL deeply into the YouTube, and you will be getting the videos for digital electronics there if you are interested in that also. But for this particular course, like I'll be uploading the video from today only, so this video will be uploaded in this particular channel, and also the you will get the PDF link of the solutions in the particular, I guess there was some drive that will be shared by NPTEL to all the students. So you'll get the solutions for this particular PDF in the document in the Google Drive link form. So if you have any like problem reaching out, you can even mail me anytime. So I am also typing out my mail. So if you have any query in between the weeks, you can mail me anytime. I'm there available all the time. Okay, so I have got some doubt about MOSFET. Okay, so yeah, so MOSFET, for this particular thing, you need to be aware of the basics first. So MOSFET is a topic of week 7, if I'm not wrong. Like I'll be covering a very like deeply the MOSFET. Even Professor Imani will be covering a very deep understanding of MOSFET and this particular problem only, that why do we ground the substrate? Because we want both the junctions, that is source substrate and the drain substrate, that is reverse biased, so that there will be a very less reverse breakdown current or the reverse leakage current, what we can say. So I'll be explaining all these concepts very deeply in the upcoming weeks. For now, we'll be sticking to very basics. So I've got a lot of introductions in the chat box itself. I guess Bhavna, you raise your hands. Do you want to introduce yourself or you have already written?
Hello, sir.
Yeah, hello.
Good morning, sir. My name is Bhavna. I am from Jodhpur. Recently, I have completed my BE degree in MBM University from electrical branch.
Okay, so you
And
have completed
now,
your BTech.
yes, and now I'm taking admission in NIT NIT Jalandhar VLSI branch.
Okay, yeah, that is great. So did you try for
So,
IIT Jodhpur? Actually, I am from IIT Jodhpur.
sir, IIT's forms closed, and I haven't tried that.
Yeah, yeah, okay, fine. Yeah, that is fine.
Yes, sir.
Yeah. Okay, so anyone got the answer to this problem? I guess we have. Um, is there any problem solving in this particular question? Any answers, or even if anyone wants to tell what have they applied, what are the different methods that you have tried, or shall I solve it directly? I can do it. Okay, so maybe I can go ahead. So this question clearly states what we have is we have given uncertainty in the position which is given by 8 angstrom. which is nothing but 8 10 is per minus 10 meter. Then we know the potential, oh, sorry, not the potential, but the momentum, which is 1.2 10 is per minus 23 kg meter per second. And what we need to find is we need to find the uncertainty in energy. So this is where the twist comes. So this is very easy. We know that according to Heisenberg uncertainty principle, okay, so we have already been given the uncertainty in position. So from here, what we can do is we can calculate the, I have a weird habit of writing this square, uncertainty in the potential. Sorry, not in potential, but in momentum. So I'm just keeping all the values, and this is 8 angstrom that is given in the question, which will give out some uncertainty in the. So can anyone tell what is this particular potential momentum that you are all getting? The value. So not sure about the value. Can anyone calculate it quickly and let me know?
Sir, it is 8.62 into 10 to the power minus 22.
Okay, so I'm assuming this is correct. So what we need to find is we need to find the uncertainty in energy. So energy, we all know that energy is nothing but momentum square by twice of mass. So what we can do is we can differentiate both the sides to calculate the. So this will be 2p by 2m. This 2 will get cancelled. And what we get is this uncertainty in energy will be equals to p by m times uncertainty in momentum. So this is what we have in our hands now. So we have this delta E, which is P by M times delta P. And we already know all of these things. So if I just write P is, what was P? 1.2 10 to the minus 23. Then we have a mass for electron is 9.1 minus 31. Then delta P is calculated by, I guess, Sushoban, you gave the answer. I'm assuming that it is correct.
Sir, it would be either a 10 to the power minus 26. I just made a mistake.
Okay, okay. So this is 26.
Yes, sir.
Okay. So it is 8.62 plus minus 26. So this will come out in joule. So what I'm doing is I'm dividing it by uh, the charge to convert it into electron volts. This is because the question has asked the uncertainty in electron volts. Got a query once again. Which sum? Okay, so I'll go through it again. So we all know that the de Broglie principle, sorry, the Heisenberg uncertainty principle states this. So we already know what is the uncertainty in the position. From here, we have calculated the uncertainty in momentum, which we have got a certain value. And we know that energy of any particle is given out by this expression, which is momentum square by 2m. Then what I have done is I have differentiated both the sides to calculate the uncertainty in energy, or the change in energy basically. So if I differentiate E with respect to momentum, so it will be dp dE by dP. And again, like differentiating the RHS with respect to momentum, it will be 2p, because p square will be differentiated using uh, like x raised to power n is nothing but n x raised to power n minus 1. So this will, from where 2p's come, and 2m is constant, so I've kept it same. The 2 and 2 are getting cancelled out. So we are left with p by m, and this dp will come in the RHS with respect to the change in, or the uncertainty in position, momentum. So from here we'll be calculating the uncertainty in energy, which will be p by m times uncertainty in momentum, and I've kept all the values. So maybe anyone, you can tell me what is the value that we are getting. That will be the answer. So I'll also try to calculate using my calculator, and you can also calculate. questions.
Hello.
Yeah.
Sir, why we divided by 1.6 into 10 to the power 19 in the end?
So this energy was in joules. To convert it into electron volt, we know that 1.602 into 10 to the power 19 joule is 1 electron volts. So the question has asked the energy in
In
electron volts.
electron. Yes. Okay, sir.
Yeah. So I think this delta P is also wrong. I'm trying to calculate it again. You can confirm. This is, I guess, 6.46 10 to the power minus 26.
Yes, sir.
Yeah. So this is not 8.62. This is 6.46. So I'll write the values here. So, yeah. So what I'm getting is around 5.3 something electron volts. Is this the case with everyone? Maybe the energy range is around 5.3 to 5.4. That is what the answer will be. Please confirm if you are getting the same.
Yes, sir.
Yeah. So this is how we have calculated the uncertainty in energy. So I hope this is clear. Maybe we can move forward to the next problem now. Okay, so this problem states that a electron and a photon, sorry, a electron and a photon have the same energy. So let's say I'm denoting the energy of electron with EE and photon with EP. So what the question is saying that the electron and proton both have the same energy. So the question now states that at what value of photon energy in kilo electron volt will be the wavelength of the photon be 10 times of that of the electron. So wavelength of photon should be 10 times of wavelength of electron. We need to find that energy. So this is very easy. I mean, maybe you can give it a go in 2 minutes, and if you are not able to calculate, I'll solve it. This is very easy question. You can take 2 minutes and let me know what is the answer that you are getting. Okay, just to give you the hint, we already know that using the photoelectric effect, the photon will be energy will be hc by lambda, and we have already calculated the energy of electron in the previous question, which is p square by 2m. And according to de Broglie, again, we know that uh, this p is lambda by sorry, this p is h by lambda. Yeah. So you can like use all these things to get the answer. This is very easy, purely numerical problem. You can take 2-3 minutes and let me know the answer quickly, otherwise I'll solve the same. Anyone with the answer? Okay, so do you need more time or shall I start to solve? You can quickly type in the chat box whatever you want so that we should not waste. Okay, fine, I'll solve it. Okay, sorry. So we know that, give me a moment. Yeah, so it is nothing but p square by 2m, the electron. So I can write this h square by 2m lambda square. So I am writing it lambda e because I'm using the same notation. Then the energy of photon is hc by lambda or hc by lambda p. That is what I'm using. Yeah. So what is given is this E of electron is given equals to E of photon. So I can write h square by 2m lambda E square is equals to hc by lambda p. And what we now want is this lambda p should be 10 times of lambda E. So I'm just substituting this here. So this will be 2m lambda E square is equals to hc by 10 times of lambda E. Is there any doubt till now? Please tell right away if there is
No,
any
sir.
doubt. Okay. So this h will be cancelled. This one lambda e will be cancelled. So we what we get is lambda is this will be 5. Sorry, 5 will come here. 5h by mc. So we know all these things. This will be 6.626. This will be 9.1 10 to the minus 31. This will be speed of light. That is. So again, can you calculate this quickly? So whatever lambda e we will have, the 10 times of that will be lambda p. So quickly let me know what we are getting. I'll also solve it. So what I'm getting is 1.21 and is per minus 11 meter. So basically this will be 1.21 10 is per minus 10 meter. Are you all getting the same?
Yes, sir.
Okay. So now what we need to find is we need to find that energy in kilo electron volts. So this is very easy. So now this will be hc by lambda. So I guess there might be a shortcut that should have been told to you in the classes, that is 1.24 divided by lambda if we write it in micrometer. So this will give the direct electron volt relation. Otherwise this particular relation will be coming out in joules. Do you know about this relation?
Yes, sir.
Yeah, so you can go ahead and let me know the energy that is coming. So what I can write here is 1.24 lambda in nanometer, so that I can write this as kilo, because I want 10 raised to 3 times, so I need to divide it by this. So this will become nanometer. So you can use the same. Okay, so I can write it directly. This is 1.24 divided by 0.121. That will be coming out in dash from S9. So this will be the answer in kilo electron volt. So let me know. Uh, so I'm getting 10.25 kilo electron volts. That will be the answer to this question. Is it clear?
Yes, sir.
Okay, is it clear to everyone? You can type in the chat box.
Sir, that 1.121 into 10 to the power minus 10.
Yeah. So okay. So what I can write this as 1.21 10 is per minus 4 micrometer. So this is what I need to feed here. So maybe I can do it for you so that it will be easier. So energy will be 1.24 1.21 times 10 is per minus 4 electron volts, since this is in micrometer. But what I want this in kilo electron volt. So I'll multiply it by 10 is per 3 to get this. So I'm getting 1 point. So 1 will be 10 is per minus 1 and 1 will be 10 is per, sorry, minus 3. So this will be 1.24. This particular thing will be 0.121 and this thing will go above. That will make it 1.24 divided by 0.121 kilo electron volt. Does it make sense?
Okay, okay, sir.
Yeah. Fine. Okay. So shall we go ahead?
Yes, sir.
Okay. Like this is a very basic problem. You can try it out. You should not take more than 2-3 minutes to solve this. This is very easy. You just need to find the kinetic energy. Everything is given and the unit should be is milli electron volt. After 2-3 minutes, I'll start to solve the same. Anyone with the answer? So okay, let me solve it. This is very easy. So we have this kinetic energy which is half mv square. We know the mass for the electron which is at rest, and then the velocity is also given which is 7 centimeter. This will be 10 raised to 5 meter per second. This will make it, the square will make it 10 raised to 10. And to convert it into electron volt, I need to divide it by 10 raised to minus 19. So this will be the answer in electron volts. Okay, so let me quickly solve this. I'm getting 0.84, which will give me 28.4 milli electron volts. The answer will be 28.4 milli electron volts. Is it fine? Is it the case with everyone?
Yes, sir.
Okay, fine then. Let's proceed. So now this is a very similar problem. Please try to solve it by yourself. We need to apply the same approach as we did in the previous problem. We need to just calculate the change in kinetic energy if the velocity that we have in the previous question was 10 raised to 7 centimeter per second. It has, if it changes to 100 centimeter per second, or you can write it as 1 meter per second, what will be the change in the kinetic energy? Uh, shall I give you 2-3 minutes, or shall I solve it? You can tell directly. Yeah. Meghala, do you have any doubt? Okay. So shall I solve, or you will try it for 2-3 minutes? Okay, so I have some query. So the two that I will do. Yeah, so in IIT Jodhpur, master program is going on from so long. I mean, in VLSI only. Yeah, so we have a program in VLSI. Like the admissions have been completed. So like you can mail all of these queries over email. This will be better. I've shared the email in the chat box. I've pinned the comment also. For now, let us focus majorly on the question part. Yeah. So yeah, what I was saying is, do you want to solve it, or shall I start to solve it by myself? Please try to respond quickly, everyone. Okay, so I'm not getting any response. I'm assuming I need to solve it. So we know that this is half mv square. So there is a change in velocity. So if I do the differentiation, I'll be getting the change in kinetic energy as 2v delta v. So this 2 will get cancelled. So the change in kinetic energy will be mv delta v, and we all know the things. So this is 9.1 times 10 raised to minus 31. Velocity is 10 raised to 5 meter, and then delta v is 1 meter per second. Yeah, so this is, I guess, direct. So this will, I guess, okay, so this will come out in joules. So now to convert this into electron volt, we need to do a further division. So it will be 9.6. Okay, so this is minus 26. This is minus 19. So this is minus 7 electron volts. This is 5 point something. It will come. You can see 5 point.
686.
Yeah, something like that. Is it clear, everyone?
Yes, sir.
Okay. So let's proceed ahead. So now I guess more of the problems will be from this year's assignment. So let me know if the problem is exactly same so that I can change or I can frame the question with some different values. So do you have this problem in this year's assignment?
Sir, in the previous question,
Yeah.
why we have multiplied in delta kinetic energy 2V into delta V?
Okay. So what we have is we have a kinetic energy as half mv square.
Yes, sir.
So if we differentiate it with respect to we can say velocity because that is what is changing. What we get is 1 by 2 mass and the velocity will be 2v. The differentiation of v square will be 2v.
2V, yes, sir.
So this is the change in kinetic energy. I'm writing it as delta kinetic energy. This 2 and 2 is getting cancelled. We have a mv and we have a change in velocity.
Okay, sir.
Yeah.
Okay, thank you, sir.
Yeah, no problem. So please someone tell if the question is exactly the same that is given in the assignment.
Yes, sir.
Okay, it is exactly same. So let's say we have a wave function. Maybe I can take one part of it. Then you need to find the energy of the particle. So this is the question. Let's remove this part. Do you want to try it or shall I again do it by myself? Uh, Please confirm quickly. I can wait for 2-3 minutes if you want to. Otherwise, I'll solve it.
Sir, solve it, please.
Okay. So we need to have some understanding of, I guess, quantum mechanics in this particular question. That is, I'm assuming that covered in the theoretical course also. So we have certain quantum operators. So first operator that we should be knowing of is a momentum operator. So momentum operator is nothing but so I'm just writing the operators that comes out after solving. So this is nothing but h bar by j d psi by dx. So this psi is the wave function and this is nothing but the momentum operator. The second is the energy operator. So I'm writing for both time dependent and independent. I guess in the classes you might have covered the independent case. So the total energy operator is given out by, maybe I can write it in the LHS again, minus h cross by j d psi by dt. So this is the energy operator. And the third case, for the time independent case, that is what in the question is, we have a kinetic energy operator. That is what we have is minus h square by 2m d2 psi by dx2 is this kinetic energy operator. You can write it something like this. So these are the three operators that you must have read in the during the lectures also. So what we have is we have already been given a wave function. So we need to calculate the energy of the particle. So since we don't have any time dependence, so that all the energy will be coming out from the kinetic energy. So what we need to do is we just need to double differentiate whatever the wave function is and we'll get the kinetic energy operator. So maybe you can give it a try. This is very easy, the differentiation. So the wave function given is ikx. And let me know what is the answer that you are getting. You can take 1-2 minutes now. Any answers? Okay. So let me do it. So d psi by dx will be ik, since exponential x, the differentiation of exponential x is exponential x, or exponential of ax is a exponential of ax. So now I'll do the double differentiation. This is I square k square e raised square minus I kx. I square is minus 1, so I'm writing minus k square. So this is what the second derivative is. We just need to feed it here. So the energy operator will be, or the energy of the particle will be minus h cross square by 2m times basically minus k square, because this is again psi. So I can write this as minus k square psi. And that will come out to be h bar square k square by 2m. So this will be the kinetic energy. So this will be the answer. Any doubts here?
No, sir.
Sir, I cannot get this question, sir.
Okay, yeah. Can you see my screen? I guess it is.
No, sir, screen is stopped, sir.
Yeah. Let me rejoin. Is it visible now?
Yes, sir.
Yeah. Okay. So the question was, we need to find the energy of the particle and we know the wave function.
Yes, sir.
Yeah. So energy operator, you must have read in your classes, is given by this particular thing. So I'm writing it again. Maybe I try to solve it slowly. So this is minus h square by 2m d2 by dx2. So this is the operator, and if you want to find it for the wave function, so this is minus h square by 2m d2 psi by dx2. And we already know that the psi is e raised per ikx.
Yes.
So yeah, what I have done is I have double differentiated this particular thing to feed it here. So let me do the first differentiation. So this will be ik times e raised per ikx, because e raised per ax has a differentiation of a e raised per ax. If there is a lot of noise, maybe you can mute yourself. And then ik remains the same. Then again it is ik and exponential of ikx. So this is what I have written: I square k square e raised per ikx. And I square iota square is minus 1. So this is what I have written for the double differential. Does it make sense till now?
Yes, sir.
And this ikx is the wave function itself, right? So this, what we can write is d2 psi by dx2 is nothing but minus k square psi.
Sir, last one, what were you saying? K square psi?
Okay. So we know the wave function that we have is e raised per ikx.
IKX.
And this is what we are getting here. So I'm just replacing this thing with psi.
Okay, sir.
Yeah. And now we have already calculated for the energy operator, which is here. It's not doing this thing only. So Ke psi will be minus h square by 2m, and whatever I'm getting, so this is k square psi. So this will be the energy and this will be the operator. So the kinetic energy of the particle will be given by this thing. So this will be minus h bar square by 2m and k square. Fine.
Okay, sir.
Yeah. Anyone else having any doubts?
No, sir.
Fine. Okay. So maybe we can go to the next problem. You can try it out by yourself again. See, you need to try some of the problems by yourself. Otherwise, if I am telling you the solutions directly, it will not help. You should apply your mind also first, and then, and even these problems are very easy. So you should give it a go. If not possible, then I'll solve the problem. So do you want to take 2-3 minutes? Please confirm, otherwise I'll solve. I don't have any problem.
Yes, sir. We would like to take 2 minutes.
Sure, sure.
Sir, the answer is 11.63 into 10 to the power minus 7 meter.
What is the power that you said?
Minus 7.
Okay. So anyone else with any answer? So let's try it out. I've got one of the answers. So this is a case for infinite square well. So this is what has already been covered. Is it the assignment problem again? can you please confirm? Please confirm if this is the assignment problem as well. Uh, Am I audible, guys?
Yes, sir.
Yes, sir.
So this is in the assignment.
Sir, I'm checking it. Actually, I have not checked the assignments. I don't know whether it is there or not. I'm checking and confirming.
God. Okay.
You could proceed for the next question. If it is not there, then you could again come back to this one.
Yeah, maybe I can go ahead. So the length of the width is given by 1 nanometer, and what we know is what we want is a transition from the excited state to.
This question is from the assignment, sir.
Okay, fine, fine, no problem. So we have a E2 and we have a E1. So we'll calculate it from directly the formula that is given out. So E2 is h square by, so it will be 2 ml square because n square will be 2 and E1 will be h square by 8 ml square. So what we want is we want the change in energy to calculate the wavelength. So this will be h square by uh, maybe ml square. I can take common. This will be 1 by 2 minus 1 by 8. So this will be 3h square by 8 ml square. And what we want is wavelength. So we know that energy will be nothing but this change in energy basically will be hc by lambda. And we already have this value. So lambda will be hc by 3h square by 8 ml square. And we know each and everything here. This will be 3h, this will be 8 ml square. And so is it asking? So yeah, so this will be the lambda. Oh, sorry. This will be the lambda in meters. So these are all constants. You can keep the values and you will get the answer. Is it fine?
Yes, sir.
Okay. So again, is the problem there? So let's change the value even if it is there or not. So this is, let's say, 2.3 electron volts. So we need to find the cutoff wavelength. So the instructor has already given the direct formula to find it in electron volts. So this is nothing but, sorry, yeah, energy in electron volts. So this will come out in micrometers. Which question you are asking about? Which particular question? The last one or this one? Sakshi, could you please confirm? Uh, this question you are saying? Okay, fine. So what we have is in this particular question we have an infinite well which is having a certain length, or we can say a certain width. Maybe you can draw here, yeah. So let's say this is a infinite well in which we have a potential, infinite potential everywhere except we have a zero potential in the well. So here it says if the electron undergoes a transition from the n equals to 2 state to n equals to 1. So what will be the wavelength of the photon? So what we can do is we know that the energy is quantized for the infinite potential well, and we can calculate the energy at second and the energy at first. So this will be the basically the energy that is coming out uh, for electron that is going from the second energy level to the first energy level or the ground state. So this is what we have calculated. So E2 will be given by if we can keep this NH2, so this will be sorry, if we can keep this NH2, so this will be 4 times h square by 8 ml square. So this will be E2, and if we keep this NS1, so this will be E1. And the change in the energy will be the transition energy. That is what I've calculated by 3h square by 8 ml square. Is it clear till here? Yeah, so once we have the energy, we can easily calculate the wavelength. So E is nothing but hc by lambda. You know everything. Hc and this m, h, l, everything is given. So you just need to calculate the lambda. Is it fine? Okay. So yeah, we can calculate the cutoff wavelength in this particular
Sir,
question.
is the answer 0.53 micrometer? This question.
Yeah, so it will be zero point 0.5 something. Yeah, maybe a 0.53 micrometer. This is a very basic question. Maybe we can go ahead directly. So is this the question in the assignment? Okay, so I hope not. Am I audible? Sorry for
Yes,
the
sir.
glitch. Yeah, sorry. Okay, yeah. So yeah, so we have this question now. In this question, it says that we have an electron with an energy of 1 electron volt impinging a potential barrier. So we have a potential barrier V naught, which is 5 electron volts. In the first case, the width is 0.5 nanometer. And assume the tunneling. So there is a concept of tunneling probability that you might have read in the classes, that the tunneling probability depends upon the width or the position. It is given out by E2 gamma x, where this gamma is nothing but the decay constant, and this x is again the position, and this gamma is formula wise it is given out by 2 m naught v minus e by h bar square. So we have two different cases. One has a width, let's say this is a1, and one has a width of 2 nanometer. We need to find out the relation between the both the cases of t. So okay, so to make it very easy, so let me write t1x. So let's say e raised to power minus 2 gamma x1, which is what we have. This is, let's say, x1. This is, let's say, x2. T2 is nothing but e raised to power minus 2 gamma x2. So we need to find the relation between this T1 and T2. So what I'll do is I'll divide both of them. So T1 by T2 will come out to be e raised to power minus 2 gamma x2 minus x1. Does it make sense? Is it clear till now?
Yes, sir.
Okay.
Yes, sir.
So we already know that we have e raised to minus 2 gamma. X2 is 2 nanometer. So this will be 2 minus 0.5. So what we can say here is T1 is exponential sum minus negative term, which is 1, let's say 1.3 gamma. No, yes, times T2. So what we can easily see that T1 will be very, very less than T2. Does it make sense? I've done it correctly. Maybe I've written it. So if I take minus x1, yeah, so this will be not minus. So there will be not a minus here because I have already kept it inside. So this will be 2 gamma x2 minus x1. Is it clear this step? I've made some changes. Please confirm if this is clear. So if I divide both of them, so and if I take 2 gamma constant, so my numerator will give me minus x1 and the denominator will give me plus x2. So that is why this will be like this. So this will be plus e raised to power 2 gamma. Is it clear to everyone?
Yes, sir.
Okay, yeah. So this will be now plus. So maybe the relation will get reversed. T2 will be very, very less than T1. Any doubts in this particular question?
No, sir.
Okay. So we'll wrap up the session quickly. So now this is the question. Do you want to try it? So we have again a 1D potential box in which we have some energy levels. So E1 is the energy of ground state, En is the energy state. So we need to find the ratio of the energy emitted for n equals to 3 to n equals to 5. So do we have this question in the assignment? Even if we have, so you can change this to n equals to 2.
No, sir.
If we don't have, then it is fine. Try it out. Do you want to give it a try? Please let me know, otherwise I'll solve it.
Yes, sir. We will try.
Okay, fine. You can take 2-3 minutes.
Sir, is the ratio 1 by 24?
Sorry, 1
1
by
is to 20. 1 is to 24.
24. Okay, so we'll let me see some more answers and then I'll solve. Anyone else with any answer?
Not that, sir.
Okay, you can try. We can take 2 minutes more. Okay, so let me try to solve it. So what we need to find out is from 3 to 1 to 5 to 1. So for 3 to 1, we need to have E3 minus E1, and for 5 to 1, we need to have E5 minus E1. E3 minus E1 will be, so this will be 9, this will be n square h square by 8 ml square minus h square by 8 ml square. So this will be 8, so this will get cancelled. Sorry, there will not be any 8. H square by ml square. So similarly, E5 minus E1 will be 25 h square by 8 ml square minus h square by 8 ml square. So this will be 3h square by ml square. This is what we need to find, 3 to 1 to 5 to 1. So I can see this is basically 1 by 3 only. So how come you get 24? I'm not sure. Do you see your mistake?
Yes, sir. I didn't count the 8 in the denominator.
Okay, yeah, that is fine. So even we can do it directly also, like we can write directly, because we know that it is the energy is directly proportional to, give me a moment. Yeah, so the energy is directly proportional to n square. So we can write it directly, like for 3 we will have 3 square minus 1 square divided by 5 square minus 1 square. This will give me 8 by 24. That will be 1 by 3. So the answer will be 1 by 3 only. So is there any doubt in this particular problem?
No, sir.
Okay, fine, then we can wrap up the session for today's class. And again, so this video will be uploaded on the YouTube channel. So you can search again my name with NPTEL. You will get a channel in which there will be already some videos for digital electronics, but for this course I'll be uploading the videos from today only. So you can search my name and you will get the videos. You can subscribe this channel to get videos weekly. And then what else? You can mail me anytime if you have any queries in between the lectures. So this is my email ID. So yeah, so with this we can conclude this week's lecture, and we'll meet the next week same time from 6 to 8 to cover the content for the week 2. So yeah, thank you everyone for joining, and I hope there will be a regular participation from all of you.
Thank you, sir.
Yeah,
Thank
thank
you,
you
sir.
everyone.